Then I'll start. So, yeah, hi. My name is Huib Kleinhout. I'm a product manager working in Google Stockholm. And I work primarily on WebRTC. And Stockholm is over here on the map. It's in northern Europe, Sweden, where the red dot is. So we're far apart. It's right now it's 2 a.m. In the middle of the night here. But I'm very happy to have the opportunity to talk at the Korean events. I will hope that someday I will be actually able to visit your beautiful country. I'm very much looking forward to that. So Sweden is known for its furniture, IKEA. It's also known for ABBA, but most of all, Sweden is known for WebRTC. And WebRTC very much started in Sweden. It started in 2011 when Google acquired a company and open sourced all the source code and started integrating the technology in the browsers. Now in 2018, where are we at now? We see that in Chrome alone, there's almost 2 billion weekly audio-video minutes using WebRTC, and with a 300% growth from last year. So it's used a lot in the browsers. There are more than 1,300 WebRTC-based companies and projects that are tracked, and there are definitely a lot more that are not tracked by this tracker. And more than 80% of the installed browsers, the browsers that users have, they may be old, they have WebRTC built in. We also saw more than 10,000 downloads of the Android pre-compiled libraries of WebRTC from the WebRTC.org website, and similarly, like more than 6,000 for iOS. So the mobile platforms are very popular. You can see that users many developers download the libraries and start integrating WebRTC. Within Google, we also use WebRTC for all kinds of services. Quite recently, YouTube's the live streaming service from Google, also switched to WebRTC from old RTMP, and just this switch, it's pretty much default settings, decreased buffer rate significantly, and increased the quality a lot. And this means like fewer times users have to wait for see a spinner for the video to appear. WebRTC is also used in other apps such as Hangouts Meet, Duo, if you make a call on a home device, or if you make a call from your self-driving car. So WebRTC is literally everywhere in Google products. One major effort that we've done over the last years has been around WebRTC 1.0. Basically, the first version still of WebRTC, and this was spread fourfold. One is about specs, so how things are documented. The other one is about compliance, how well browsers follow the documentation. Then to make tests and being able to verify that it works every time. And reliability, making sure that like every time you do a call, it works reliable when you need it. And completing version 1.0 is basically going from a version that's like, it works on my machine, it almost works all the time, to something that you can really rely on. Meaning that if you're going to have a meeting or a remote session, that you know that the communication will work well. And there's the WebRTC pipeline is complicated. It's a complex set, when going from capturing audio and video to processing, coding, transporting it over the cloud, and doing the inverse back to playback the media. A lot is involved. There are different standard bodies involved here. The two main ones are WebRTC. These are standards for that platform. The other standard body is IETF, which is lower protocols. So, for instance, for net traversal or for how data is packed up. And in between, there's like more or less independent standard bodies for the media encoding. VP8, VP9, H264. So there's a lot of standards involved that need to all play in line to be able to communicate. If you look at the main standards from WebRTC and IETF, basically all the main standards are now stabilized. They have reached that recommendation PR, WebRTC, which means they are about the process of being improved. Similar on the ITF side, where the main specifications have reached RTC status or are in the process of doing so, which means that they're also finalized. So here on the spec side, we see that yes, WebRTC 1.0, we have a very stable, we're close to having a very stable specification and documentation of what's in WebRTC is. For standards compliance, meaning how the browsers use these, a lot has happened. Initially, only Chrome and Firefox supported WebRTC, also Opera. And at some point, Microsoft came with another alternative proposal for the WebRTC APIs called RTC. And this RTC was better standard, better API, but it was also largely incompatible with what was already developed. So this caused a breach in the standards. And after a lot of discussion and collaboration in the working group, there was an agreement to merge some of those ORTC APIs into WebRTC and then complete that as version 1. And a lot revolves around what they call SDP merging. So this is an underlying text description of the session. In practice, we see the developers have to get this text description and make the modifications to it. This makes it highly susceptible for problems. And with the object API, we aim to avoid this and have a better, cleaner API. Looking at the APIs that are part of C1 was API, 0 APIs in Chrome, we added a lot. So since over a year ago, we started implementing key APIs that were merged over from Microsoft Edge, these object-based APIs, and we aim to switch to a new SDP format, the standards compliance SDP format in Chrome 72. Currently, if you've done Chrome, the stable version of Chrome is Chrome 70. You can see that there is a lot of each one of these, a lot of objects were added. And why this matters so much is that it makes it possible for a developer to just follow the specification and write it once and it keeps it on. And right now it's still quite complex to make the service work. So as a matter of fact, in this presentation, we plan to do on another conferencing system. That's because I used an early version of Chrome that deprecated APIs. That didn't work. So we see it's really a problem for web developers that APIs keep changing, and we really want to make sure that this version 1 API is stable and very predictable. These APIs, web APIs, they are accessible by JavaScript developers, but underlying there's a C++ API, the peer connection API, and often there is APIs have a direct connection to the C++ API. On top of the C++ API, there are also iOS and Android APIs, Java APIs. So whenever we change something in the lower layers in C++, we will see it reflected in all the APIs across the platform. And all the browsers except Edge, they use the WebRTC form, WebRTC implementation. Chrome is always using current, so the latest version, and the JavaScript layer follows the C++ layer, very much. Firefox is not so much behind. It has more custom implementation on top of this, top of the C++ layer. And also Safari, which got their WebRTC implementation did over a year ago, is following the WebRTC code, but more closely follows the C++ layer. You'll see that, therefore, that Safari and Chrome have a similar, more similar implementation with WebRTC. Microsoft Edge is currently using a proprietary library, but we have the vertical signals that they also aim to be more standards compliant. So on the testing front, there is a large industry effort to test web platform APIs. And there's test suites, we develop test suites for both the peer connection, the WebRTC core API, and the API for media, getting media, get user media. And these test suites are run daily on different platforms and different browsers. And as you can see, they're still below red, meaning that the browsers are not fully compliant yet. And we want more green. Part of the problem has been that for making the test work, there had to be camera access and microphone access automated, which didn't happen automatically yet until the test failed. Looking at where we are in tests, past results, I see that both Chrome and Safari have similar past results, like where they have a good coverage for camera. There's also increasingly good coverage for peer connection, where actually set data. And for instance, this increased for Chrome from around 30% to 44% over the past. And once we switch to Unified Plan, we'll see a big jump in percentage as well for volume. Firewall has traditionally more compliant already on peer connection, as you can see, and Microsoft Edge is still quite small to get there. But these numbers are growing by the day, which is really great. Another part of testing that we developed is that the traditional web platform test, which for standards such as HTML, CSS, there is just a website, a web server, and interacting with the browser, that it loads in the browser. So a very simple client server model. But with WebRTC, you always have peer-to-peer communication, possibly through another server. So there will be two parties involved. And that is a setup that has not really never been tested yet. It's a unique situation for WebRTC where this kind of testing is needed. And for that, we collaborated with the Mac speaker, Cosmo, on developing a test system which automatically tests end-to-end peer-to-peer connections in different be physically running on a machine, they can be hosted somewhere or virtualized, and they communicate together and present test results in a test code. More will be in the next session about this, in practical test codes. So lastly on reliability, we worked a lot on this. So when you have media flowing from one end to the other, there's a lot of things that can go wrong. The hardware can fail, the software can fail, but it can be also user problems, such as they accidentally use their own phone. We have to make it more reliable that WebRTC applications in the browser. We implemented signals that you use developers can track information about the system in order to understand the media status. For instance, where you get an event if there's a hardware or software fault. There's also been many fixes that inside the program to make it more reliable. So, as you can see here in the long list, there's we've done like small fixes from just web fixes to complete rewrites inside the program to make sure that like media really works reliable. So most of the time, but all the time. In the current version of Chrome, they're experimenting and releasing a new way of processing audio, which completely isolates audio and makes it very robust. One particular important fix we did last year, where we resolved a very long-standing issue in macOS, where audio capture would fail up to 80% of the time. After deep investigation, we understood it was an operating system problem, and we were able to work around it, which decreased the failure rate significantly. We also have been working on a new echo transfer for the past 2 years. This has been specifically designed for desktop and pretty much eliminate all the cases where you would accidentally generate echo from a desktop endpoint. This echo transfer is also in right now in the current versions of Chrome, and will be rolled out in the near future to everyone. In practice, it means that users have more clear sound and echo is becoming rare. Another key piece in reliability has been string share latency. So if you send string share updates like this, with a frame rate by 5 frames per second, then in all versions of Chrome and WebRTC, you could get in an extreme circumstances, you could get a very long lag, like tens of seconds. So if you change from one slide to another slide, for instance, due to congestion and retransmissions. With MCC3, like last year, we fixes. This can be in worst case, and then 99% are reduced to just a few seconds. As mentioned, we reworked all the audio in Chrome to make it run completely in its own process, where it can auto restart on failure. And it's quite common that audio devices or audio software fails or time travels. But what's coming soon is we're working heavily on Huib SVC. Huib SVC provides a much better visual quality at equivalent rate. And this practically means that if you run that you have more endpoints, that you can get an HD type of experience even on like more poor connections. Also, the libtripx developers have improved the efficiency of 59 a lot, meaning that encoding of 59 is only now a small marginally more CPU intensive than 58, and decoding already inside of the WebRTC library and inside of Chrome, which work pretty well. We've seen some projects switching completely live and very successfully. And let's then get some slides. There are also a lot happening. So, not earlier this year, Microsoft Edge introduced support for Get Display Media, the official standardized way of capturing content from the screen. And Firefox already had a similar implementation, and it is also switching to the standard implementation. And because of that, we decided to also want to follow the standard implementation, Get Display Media. You can try it out in Chrome version, Chrome 20, with a special flag. And more features will be added to the upcoming Chrome releases. Also, Safari is under in the WebKit and is developing support for this. So, yeah, hopefully over the course of the coming half year, you, as a web developer, can completely switch to one API for sharing or capturing screens instead of doing the implementation for each browser separately. So this is also a big step towards like having a unified API. So concluding WebRTC 1.0, it's a large project, more than 6 years of engineering. It's really open source based on open standards and now implemented in all browsers. It's reaching billions of endpoints. And what it means is that what it unlocks WebRTC is that you can do things like combining WebRTC with WebGL to create shader-based video processing, to all sorts of effects with camera. You can use advanced AI in communications. You can set up game streaming, for instance, with screen capture APIs, real-time game streaming, or you can receive web applications doing video mixing with canvas capture. Now in Chrome 17, Chrome supports installable web apps. This is already supported in Microsoft Edge. There's support across the industry for this format. It means you can build packaged applications straight in the browser and use all these technologies together. It works cross-browser. It's fully sandboxed and instant updates. And really, WebRTC really unlocks a lot of new use cases. And with that, we can finally start having fun with the browser.